My name is Lisa Downey and I will be hosting this afternoon's webinar. So we have some incredible speakers with us this afternoon. We have Caroline Ashe Brady, who's the Commercial Director here at Core Group. We have Finnian O'Hanlon, who is the Technical Manager at Core Insulation. And our guest speaker today is Manuel Gonzalez Rodriguez from CG Business Consulting. So today's webinar will be discussing embodied carbon, how we can understand it, how we measure it, how we report on it. We're looking at some EPDs, what they mean. We'll also be looking at the importance of this within the construction life cycle, and we will be unpacking EPDs with Finnian, as well as looking at current national, EU and international policies, the barriers and opportunities around embodied carbon in construction, and also the plan of net zero road pathway for Core. So without further ado, I will pass it on to Finnian now to start, and Caroline. Thank you.
Good afternoon, everybody. Thank you, and thank you for the introduction, Lisa. As we go through the webinar, as Lisa mentioned, you can pop in your questions and answers, depending on how things go and how many questions come in. We might keep them to the end, or we might introduce them throughout the session this afternoon. I'm going to, I suppose we have two specialists in embodied carbon, greenhouse gas inventory, global warming potential, and all of the things that are we're all beginning to obsess about in the construction industry. So I won't keep you very long in terms of what I want to talk to you about today. Oh yes, that's cert. That's we think you can, if you want to need a CPD cert for after the webinar, you can just link out to marketing@coresystem.com. So what I wanted to, I just wanted to give you a brief overview on all of the stuff that happens within supply chains to get the data that allows us to make any claim around our global our greenhouse gas emissions and our embodied carbon. And so as a manufacturer, for those of you that don't know the Core Group, we have two aspects of our business. We're manufacturing insulation in the for the new build and retrofit market. And we also have a retrofit division where we're delivering deep retrofit in mainly the residential market on the island of Ireland. And we supply our materials both into Ireland and the UK. And as a manufacturer, we started many years ago. We could see that in the future, we could see that impending legislation, what Europe was talking about in terms of energy efficiency, in terms of carbon, that this was going to become critically important in the construction industry. And so when you are reading your EPDs or the information about embodied carbon from anybody within your supply chain, it is coming from the activities, the real life activities that manufacturers and supply chains are doing to improve their impact on the climate. So just a little before 2025, our story into all of this was a little bit diverse in that we started chasing down kilowatts. That's how I call it. Probably back in 2014 to 2015, we started looking at our replacing fossil fuels. How could we do that within the organization, but really chasing down those kilowatts to use less kilowatts for every cubic meter of material that we were producing. That's as much as that's what our ambition was at the time. And at that time there was huge support from and still at the moment for Enterprise Ireland and from SAI, and we started the process of replacing our end of use kit here in the factory. We also looked at the introduction of low carbon EPS products through Red Cert certification. We looked at we looked at our data set to get third-party verified EPDs, and we're on our second EPD now, moving into our third EPD, because all the actions that we're taking and all that data is feeding down into the result in our EPD. So it takes time to make your decision about what you're going to do monitor, implement the actions, and then monitor the data that comes out of it, looking for those savings. So we did an energy upgrade at our buildings. We electric vehicles, we've saved 1 million litres of water. We did LED lighting. So that's a lot of the low hanging fruit. But then we looked at automating our plants, replacing part of our kit with much more energy efficient machinery for production, and that was really to replace end-of-life machinery. We put energy metering on all of our machinery. We looked at waste reduction. So how could we use all the waste cut-offs from our process, grind it to a more raw material like, and bring it back in. So that whole aspect of circularity. And then we also we're working on a circular arena project where we're studying the supply chain, the potential supply chain for bio-based materials into insulation materials in the Irish market. And then along with all of this, we were looking at ISO 14001, which is the environmental standard, 45,001 and 50,001, which is the energy standard. And then we kind of came to a point where probably in 2024, where we started to say, well, what are we going to do? How can we stretch this forward and make a plan into the future? And that's when we started looking at our net zero pathway. And we were the first company in Ireland to be awarded third-party accreditation for our greenhouse gas inventory and reporting to that international standard. But what we devised is a plan from now to 2050. One thing I'll say to you about a net zero pathway for any business, it's really, really important to identify your baseline, what energy you're using now. And then you've really got to understand the technologies, where technologies are likely to go, what your supply chain, right back all the way down into our suppliers, what actions are they going to take that's going to have an impact on us, what technologies are available now. And then it's a fluid process, because every 1 to 2 years we look at it again and say, well, what has changed in technology? So for example, when we looked at HVO 8 years ago and then looked at it again when we're doing our net zero pathway, it seems like much more credible for us to introduce HVO into our transport, because the two major changes that we're going to have to make in 2022, when we're looking at our baseline, we had 24,000 tons of CO2 that we were responsible for. And the two big ticket items we need to look at is transport and our raw material to get to that net zero pathway. So this year we've solar EV energy monitoring equipment has gone into our entire plant. We're looking at our data infrastructure. How do we get data, real life data, out from all the machines, from all the sources, from the trucks? When you look at all of the data points that go into EPDs and greenhouse gas inventory, how do we do that effectively, efficiently, and make sure that we're reporting on those savings immediately, that we don't have this lag and delay in our reporting with electric forklifts. And then we also started looking at the insulation of our plant. We produce a lot of heat here, and we now have heat recovery equipment in place, so we're reusing the heat from the plant. And by the end of 2026, the things that we've done in 2024 and 2025, we will have achieved an 18% reduction in our scope 1, 32% in our and reduction in our scope 2 relative to that 2021-2022 baseline. And then, as I said, the big change comes in the next few years, where we're looking at biomass balance EPS, and where we look at biomaterials, and we're looking at how to reduce our transport even further. And then we move into 2050. But I know, sitting here and understanding what I understand now about all of this, that by 2030 this plan could look different, because technology is changing at a pace and rate that's it's incredible to see what's happening. When we look at our greenhouse gas inventory and our net zero pathway, end of life and what happens to the buildings that our products are going into 100 years from now is taken into consideration based on what we know now. But I know by 2050 we're going to know something different. We're the circular economy, how we're reusing materials, how they're going back into supply chains. So the picture's always changing. So what I want to do in talking to you today and in understanding embodied carbon is this is where it comes from. This is where the data comes from, the actions we are taking, the actions our supply chains are taking. And if there is no improvement, there's no improvement in the embodied carbon. And so we've got to constantly improve in our position and our reporting. And we've got to ensure that there's a commercial reality, that there's a return on investment, that there's that the actions we're taking in this, not only are they morally right, but they have to ensure that we have continuity in our business, that it's a fair and just transition, that nobody loses their job today because we took actions that led to the demise of businesses. So we've got to be careful. So what I'm going to do now, that's me. I'm going to be coming in for questions and answers. I'm now going to hand you over to Finnian, and Finnian's going to get more into the meat and the science, followed very much then by Manuel. That's all of that data, everything that's so incredibly important, the source of it, the accuracy, the transparency, those data sets. Emmanuel's going to really give you an understanding of that. So I'll now hand you over to Finnian. Thank you.
Thanks, Caroline. As Caroline has already suggested there, this has pretty much been a passion for CORE for a long, long time. To be honest, it's probably become an obsession now at this stage, but it's something that I personally am passionate about as well. So it's lovely to be able to combine the two things. But before we really get into it, I just wanted to kind of talk briefly about it. So over the past years, we've really been steadily improving the quality of our buildings, and we've had, improved fabric selection. We've been really strategic with our designs and how we're placing them on sites, and north, south, west facing, etc. We've even included more efficient ventilation and heating systems. But with all of these improvements, why can a zero energy house still be a significant contributor to climate change? So if you imagine you want to build a zero energy home, so you choose your high performing building fabric, you incorporate your solar panels, you've got your triple glazed windows, you've got your heat pump, and you're producing just as much energy as you're consuming. So you're proudly energy zero. But if we start to delve into it, if we start to look at it maybe just a little bit more, we realize that we demolished a perfectly good 1960s bungalow to build this. We put a basement in with 250 tons of reinforced concrete, and we've got steel cantilevers that are supporting those carefully orientated windows, and each of those was installed by a crane. Now, I'm being a little bit facetious with this, but you can kind of see where my point is. So even though we're zero energy, our total life cycle carbon footprint is enormous, and it could take 100 years of zero energy operation just to offset the emissions from all that construction. So what exactly is embodied carbon? What are we talking about? Well, I think it's very important that we say it's not the element carbon that we'll see on the periodic table. What we're talking about is a greenhouse gas emission or greenhouse gas emissions, and we express it as a CO2 equivalent. And that's just for ease of comparison. And what it refers to is the emissions that are generated before and during construction. Any maintenance that's involved with that building over its lifetime, any replacements of parts of that building also factored in, and in the end of life, so your demolition, your deconstruction. Your EPD then is all that data that's verified by an independent party, and that allows us then to compare apples to apples when we're looking at materials. Now, it's not always as straightforward as that, but it's certainly much closer, and we'll look at that shortly. In life cycle terms, when you're looking at embodied carbon, your key modules that you want to look at are modules A1 to A3, which cover the cradle to gate stage, and that's the production of the product right through from raw material to leaving the factory. Your operational carbon is the carbon that you're producing as a result of the use, and it's predominantly energy use. So things that influence that are things like your building fabric, your air tightness, your system efficiencies, and your occupant behavior as well. Unlike embodied carbon, operational carbon emissions can be reduced. So you can do things like upgrade your fabric, upgrade your heat systems, or you can even incorporate behavioral changes into that as well, lowering your thermostats, whatever it might be. So you have that option. Whole life carbon then is both of those things, along with whatever is required in the end of life. So again, your demolition, deconstruction, but there's also an optional recovery phase or stage module to that allows for reuse or recycling of materials. Now, over the past 2 decades, our operational energy use has dropped dramatically. And again, it all comes back to the better insulation, the air tightness, the renewable systems. And that's been really great news. It's a positive step forward. But what it also means is that materials and construction now account for the majority of a building's lifetime carbon. And the problem with this is that it's front loaded. It's released immediately during construction, and it can't be offset. So you also have this kind of simultaneous thing happening where global construction is generally increasing. And I know it's a little bit stagnant at the minute, but that aside, it's generally increasing faster than, say, the carbon intensity of materials like steel or cement is reducing. So really every ton that we lock in, or every ton of those materials that we're using today, locks in emissions that can't be undone. And if we go into that further, you know, the next 10 to 20 years are really critical. But the good news is that we have, you know, really powerful levers, designers, engineers, specifiers. They all have really powerful levers available to them. And it's, you know, reusing existing building stock, reducing over specification in materials, and choosing low carbon materials. And really, acting now isn't just responsible standard practice, it's really essential. And policymakers, you know, right at a European level know this. And because of that, we've ended up with this Energy Performance of Building Directive. So you could be familiar with that, the EPBD. And this is the EU's core legislation that drives improved energy efficiency and decarbonisation in buildings. Now, the SAI have developed this lifecycle global warming potential calculation methodology, which is really, really good step forward. But the slight drawback with it is that it relies on a generic emissions data, which is also expressed in a CO2 per kilogram. And that's fundamentally different from what you would expect to see in an environmental product declaration, an EPD, which typically expresses impacts per functional unit of meter cubed. Now, all this will make more sense as we go on through this, but the mismatch means that the values are somewhat open to interpretation, where you have low density materials that seem more favorable to high density materials that might seem disproportionately carbon intensive. So if we look at example at the generic values included for PIR, we'd see it looks like it is an attractive figure of 3.7 kgs CO2 equivalent per kilograms, whereas EPS is 4.78. However, if we factor in the density of those materials, we'll realize that PIR is actually 130 kilograms of CO2 equivalent per meters cubed, whereas EPS is slightly over 73. Now, in terms of the framework and what industry is doing that isn't necessarily legislatively driven, we've got the two most prevalent ones really are the RIAI Climate Action Plan and the RIBA 2030 Climate Challenge. Now, the RIAI is, you know, less benchmarked, quite aspirational, and it looks at reducing operational energy demand, cutting embodied carbon by at least 40%, reducing potable water by at least 40%, and achieving core health and well-being targets, which are all great. And slightly differently, RIBA look to set performance benchmarks. So with this, you've actually got a figure that you need to achieve. So on embodied carbon, for instance, they're assessed in 625 kilograms of CO2 per meter squared of usable floor area. RIBA actually also aligned themselves with the RICS methodology, the WLCA methodology, which is currently in V2. RICS is Royal Institute of Chartered Surveyors, and it's a professional standard for evaluating the life cycle carbon of buildings and structures. And it looks at all the modules of an LCA. So you're looking at materials, construction, operation, maintenance, end of life, and potentially recovery there as well. It gives you a consistent framework where you can quantify, and it ultimately helps designers make informed decisions. And then circling back, complementing all this, the EPBD actually requires us to report on this figure. So from the 28th of January 2028, the 1st of January 2028, all buildings over 1,000 square meters of usable floor area will have to report this figure in their BER. And equally from the 1st of January 2030, all buildings will be required to report this figure in their BER. So with all that in mind, and given the length of planning timelines here and design timelines, it's actually not unreasonable to say that whatever projects are currently in design phase will almost certainly be subject to these requirements by the time a commencement notice is submitted, which is 1st of January 2028. So, you know, you're looking at about 2 years there, which depending on the scale of the scheme, as I say, isn't unreasonable. And for that reason, your material choice and your specification at right now strongly influences the building's carbon footprint later on. Insulation in particular affects both your operational and your embodied carbon. And really that's where EPS comes to the fore. It's lightweight, you've got a high thermally performing product, and it's also a low carbon material. Moreover, it's actually also recyclable at the end of life. So you've got a whole life carbon reduction. If we look specifically then at core and core EPS, so as Caroline said, we started this journey a long time ago, and we've been working hard to, produce the lowest embodied carbon EPS in the country. We've got verified EPDs showing how low the embodied carbon content is, and again, all due to that work we've done. In addition to that, we've got biomass balance options that help you further reduce your carbon. And it's also locally produced in Ireland, meaning you're minimizing transport emissions. So ultimately, the early specification of core EPS locks in carbon savings before the construction has even started. And it actually also avoids situations where you're trying to update and change specifications closer to the site kicking off. So now if we look specifically at EPDs, it's important that we kind of give it some context before we launch into it. So what is an EPD? Well, an EPD, as I said earlier, is an independently verified document that reports on the environmental impact of a material throughout its entire life cycle. And it's developed based on standardized reporting rules. So again, it's to give you that like-for-like comparison, and especially when you're looking at embodied carbon. Your first few pages, which we've shown here, really give you details on the product, details on the manufacturer, how it's intended to be used, but crucially, it also gives you your functional units. So you'll see on the third page illustrated, you've got 1 meter squared of installed EPS 70 insulation, 100 millimeters thick. And that's very important because that is the functional unit to which all of the figures in the EPD relate. So as we go through it, we'll come across our LCA, or a life cycle analysis, and this is the real meat. This is the real data. This particular one is for core EPS 70 silver, which is probably one of our most common products for floors, particularly those with underfloor heating. And your LCA results are, as I said, probably the most relevant pieces of information when you're looking at it, particularly the modules A1 to A3. So again, that's cradle to gate. A4, A5 relate to transport and construction. So that's why we're looking at A1 to A3. What we want to look at specifically is that figure that we've circled in red, the GWP total of 4.7. And that's made up of the three figures below it, which are GWP fossil, biogenic, and land use. That's land use and land use change. So we can see that combined, those three values bring us up to 4.7 kilograms of CO2 per functional unit, which again, if we look at the top, is 100 mil of EPS 70 board, a 1 meter squared section of that. And I've breezed over it, but again, if we look at the EPD as a whole, we can see it's broken down into 4 different stages where we've got modules A, construction, modules B, use, module C, end of life, and the final one there, recovery, which is a negative figure because you're looking at recycling it or reusing it. Now, if we drill down a little bit further into that data, we can see that there are a number of little nuances to this that are very useful to know. As I said, you've got your fossil, you've got your biogenic, and you've got your land use, and that's ultimately what makes up your GWP total. But it's also worth pointing out in this that the figures are all scientific notation, and this is sometimes something that really makes looking at an LCA very difficult. And the reason it's done like that is just to keep consistency of units, but it's actually very, very easy. So if we take our land use figure, the very bottom row, we can see that we have 2.77 times 10 to the power of -4. And quite simply, that means we divide the 2.77 by 10,000. And the reason we divide it and not multiply it is because it's -4. And that results in 0.000277. If you want to get into the bones of that and you want to understand each one of those numbers, quickest way to do it is to copy and paste the figure into like an Excel sheet and just precede it with equals, and it will give you the number, which sometimes helps. Knowing all that now, and knowing that our GWP total is 4.7 kilograms CO2 equivalent per functional unit, which we also know is 0.1 meters cubed, we can determine that times 10 is 47 kilograms of CO2 per meter cubed. So now we have a usable value that we can apply across whatever it is we're doing. Now, I mentioned earlier that not all EPDs are straightforward to read, and this is an example of one that's just a little bit more complex, and this is one for PIR for comparison. So in this, we can see that the figures are transposed. So instead of our stages being along the top, they're down the side. Now, we still have what we need. A1, A2, A3 have all been aggregated, and they give us a total value of 9.4 kilograms of CO2 equivalent. But what we're missing here is the functional unit. So if we drill into that a little bit more, we'll see that we have to flick back to the earlier pages of our EPD. And we can see that 1 meter squared down the bottom right of insulation at a thickness that gives an R value of 3 square meters Kelvin per watt. Now, they've been kind enough to tell us that that's 66 millimeters in this particular EPD, but that's not always the case. So if that measurement was omitted, we would then have to determine what our thermal conductivity is and figure that out ourselves. Now, fortunately, we have it. So applying the same rules, we can work out that 9.43 kilograms of CO2 per equivalent for 3 square meters Kelvin per watt is equal to almost 142 kilograms of CO2 per meter cubed for that particular insulation. So now we've got comparative values. We can actually look at this and how would we apply this to an actual project. So let's take an easy example. If we looked at a 3-bedroom semi-D, we're looking to achieve 0.15 in our U value, which is what we want for underfloor heating. And we've got a perimeter to area ratio of 0.4. So all pretty standard stuff in terms of a housing scheme in Ireland. To achieve that with PIR, we'd need 120 millimeters, which gives us a total result of about 984 kilograms of CO2. However, if we use core EPS 70 silver, we'll need 160 mil of it, so slightly more. However, our carbon is less than half. And what you'd also find with that is you're usually trying to make up your 225 increments of your block. So you would end up with a screed of, say, 65 millimeters to do that. So again, a kind of an onset saving in that as well, because you're using less screed. I did say I would come back to this slide, and this is the SAI methodology. And if we reverse that same logic that we applied in the first place, and we take the core EPS 70 silver, we can see that that 47, if we apply the density, works out at 3.13 kilograms of CO2 equivalent per kilogram. So you can see that that's significantly less than the generic EPS value, and it's also less than the generic PIR value that's included there as well. So while the calculation tool gives us a really good starting point, it's not necessarily straightforward, and it's always good to do your own research and get the verified EPDs from the manufacturers to determine it yourself. I hope that was a useful introduction to embodied carbon and to EPDs. And at this point, I'll hand it over to Manuel.
Thank you very much. Just sound check. Can you hear me well?
Yep.
Yep.
Perfect. Thank you very much. Should I just pop mine, or are you going to share this?
You can share the screen, Manuel.
Okay, perfect. Second then. Oh, sorry. Wrong button. Are you looking at my screen? I'm just going to put it in full screen now, so I won't see you anymore then. Yeah, is it full? Yep.
Yes, perfect.
All right. Well, as you can see by my name, my very Irish accent, I'm not originally from Ireland. I'm originally from Costa Rica. I've been living here over a year. I came to Ireland last September, and it's been a wonderful journey. I'm going to survive my second winter pretty soon now. Originally, I worked on managing carbon footprint for over 22 years. I used to lead a verification validation body, which would do the verification of embodied carbon, operational carbon, for all sorts of organizations based on international standards. So my presentation will be more overarching and general about what is the framework around all the carbon footprinting, and what are the drivers, and why we're obsessed with this. As Caroline was saying, and it's because there's an urgency for I would say the global warming to be tackled, and all the frameworks that I'm going to share with you, and everything that we've been seeing so far in this webinar will help us to drive through that. The most important thing that I would like to refer is the data and the data management. A couple of things not to forget. You can manage what you don't measure. And in God we trust, all others must bring data. This was from Edwards Deming, which is pretty much the predecessor of all ISO standards management systems. If you're familiar with this concept of Plan, Do, Check, Act, it was pretty much his idea, and what I would say what started all the standardization of management system in the world. So what's a carbon footprint? And this is a definition from an ISO standard, is the sum of greenhouse gases emissions, or GHG removals, of the subject expressed in carbon dioxide equivalent. Now, what is the subject? The subject can be an organization. The subject can be an event. The subject can be a product. So when you add up all the emissions, and we've been talking today pretty much about embodied carbon and operational carbon, that was very well explained. We need data in order to measure that. and that's my insight, my key idea of this part of the talk. Just look at some numbers which I brought here that I think are very interesting. If you look at the last report, and this is from EPA, Environmental Protection Agency from Ireland, published this last year, and the two leading economies in Europe are right now Luxembourg and Ireland, and they have the largest emissions per capita as well on carbon. So this is giving us an idea of, I'm not saying that economy is directly related with carbon, but it's giving us a hint that it probably is. Upon the IPCC, which is the Intergovernmental Panel for Climate Change Assessment, on the report of 2019, they report that the construction sector is responsible for 21% of the greenhouse gases emissions. And upon the World Green Building Council, it estimates that 39% approximately is global energy related to carbon emissions that come from buildings. How this looks like, probably, and these are figures that we've taken from, and I've seen a lot of publications on this, and that's why, as Caroline was saying before, it's very important to check, to fact check, or to be verified by a third party for assurance. Figures are saying that mostly will come from operational and then less on embodied carbon. About 28% to 11% is the figure that we've been getting in some of the publications. So this is pretty much the summary. Approximately, other figures will tell us that will be around 45 to 40% on operational and 45% on embodied. So we basically need to fact check all of this to understand where the industry is sitting right now and what are the next steps. There's also a huge framework, and when I got here, I had to read a lot and study a lot just to understand all the framework that is leading or triggering all this. There's all this legislation related to the European Green Deal, the European Climate Law, the ESRS, the European Sustainability Reporting Standards, the EU Taxonomy, and all this legislation that is coming into place that recently, if you have been following this, have been a little bit diluted or stop the clock and postponed due to some, I would say, political and economical pressures on the European Union. And probably companies sooner or later will have to face the facts and will have to start performing better and doing and taking actions on tackling global warming. As you saw before, by 2028, the Energy Performance Building Directive will hit the industry and will have to report as well on energy performance of buildings. So that's, is no longer an excuse to say, well, we can wait. I think it's better to start taking early actions on all this. And that is from a legislation, legal requirements point of view. Now, from a voluntary, let's see if I can get this, from voluntary frameworks, there's also a lot of frameworks, and I'm going to show you more in a couple of slides. You have your Science-Based Targets Initiative, Carbon Disclosure Project. There are the ISO 14060 family, where the ISO 14064 Part 1 is the international standard for reporting on carbon footprints. But there's also a huge pressure of the clients and the supply chain requirements. And you from the construction industry, probably, if you're the contractor, or if you're being hired by a contractor, all the supply chain will be scrutinized to find out what is going to be the carbon footprint of whatever project you'll be working on. And in our business, CGBC Business is a consulting firm leading on sustainability consulting. I would say that most of our pipeline is from, I would say, medium to small clients, which the big companies are asking them to report on their carbon footprint. So whether it's the voluntary framework or the legislation, all of the arrow is pointing on the same direction. These are, I put together some of the international standards that are related to greenhouse gases. There's a huge family of frameworks out there, and you can get lost if you're not careful. But all of them rely on data, which was the first thing that I began speaking about. So we have to be very careful with that, because all of these standards will require data, and all of these standards can be third-party verified, which is also extremely important for assurance. This last one, ISO 14025, is environmental labels and declarations, which is pretty much the standard that is used to develop an EPD. An EPD comes along with a product category rule, which is what was explained before, to be able to compare like for like. So the framework is out there, the requisites are out there, and they pretty much apply the same way to all organizations. Now, where do we go from here? Once you have your measurement, your baseline, you need to figure out what is going to be your roadmap. And this is what Caroline presented us at the beginning on how do we set our journey to be net zero. This graph here, it could be pretty complex and not easy to understand. I'll try to, because I'm conscious of time, to explain. This is how most organizations will start. As your business as usual GHG emissions, you will have your baseline. And then you need to start understanding how you're going to start reducing and tackling global warming and your greenhouse gases. Usually what organizations will do is they will set up an ambition and timeline. And the ambition basically will mean on the targets. What will be the percentage of reduction on your scope 1, scope 2, scope 3 emissions? And you will probably start with low-hanging fruits, right? But then it gets complicated as the time goes by, and it gets more difficult, because then that means that you need to do bigger investments to do transformation of certain processes in order to get to the point of only having residual emissions. So first you work on the unabated emissions, which are basically, every project that is technically possible and financially possible. But then you will get at the end to residual emissions, which are emissions that are not technically possible or are not economically possible. For example, a cement factory, you cannot avoid using clinker, and to make clinker, you convert carbon carbonate into calcium oxide, and that chemical reaction releases a lot of emissions to the atmosphere, and you cannot change that. That would be a residual emission. What the standards are saying that only at that point you can use removal credits, which is basically, for example, a nature-based solution removal credit to counterbalance those residual emissions. When you get to that point, you can say, or you can claim, that you are a net zero or a carbon neutral organization at that point. But you need to go through this journey. In the meantime, you could use reduction credits for those unabated emissions, kind of to counterbalance, but it will be only at that moment in time when it will be equal to zero, so you can make those claims. This is just very high level, quick explanation of the definition of a net zero pathway, and this is the requirements of an international standard. And there are a lot of different or ongoing initiatives related to this, which pretty much, I would say, they all merge with the same idea of tackling the global warming and to be able to set up proper projects in order to reduce your carbon footprint. And you have to be very careful when to choose. It's very important to understand who is going to be your intended user, and also that the level of effort and investment that you're going to do will have a payback. Because of course, we have to do it for the environment and future generations, but as well, this has to be a competitive advantage for businesses in order to reach objectives and targets. It would be for those end users that, or consumers that will make decisions upon better environmental performance, and you will be rewarded with business if you're able to demonstrate that you've been gone through this journey. What are the barriers that we've been looking at working with business? Well, basically, we have different or fragmented tools and platforms, and especially, I would say, we have weak data infrastructure. Companies, are lacking of information systems that will report properly on energy performance. That we're very good to report on euros. If you go to a ledger, you have your balance sheets and you know how much you spend, how much you earned, but that's usually in euros. When we start asking about the mass of a construction, the data of all the steel, the cement that went into it, we hit a barrier there in most of the cases where organizations may not have that. And we end up doing proxies with usually spend-based emission factors instead of using a mass balance, which will be a more accurate approach. And this is probably because there are some gaps in critical skills, and organizations may not have the proper roles and responsibilities for people to do this, or to understand or have the knowledge and understanding of this. We see this, as I was saying, as a competitive differentiation. I would say that, and in some cases, not even that, I would say that is the continuity of the business. Last year, we had a client that would ask us to do their carbon footprint because they were part of the supply chain of a big pharma industry. And they told them, if you don't have your carbon footprint by the end of the year, you will no longer be an approved supplier. So that is the kind of pressure some organizations are facing. At the end, this will lead into a cost reduction through efficiency. We will give organizations a better reputation and brand value. And if you start early, the early bird will get better prices, and therefore you'll be first seen in the industry. What are the main steps? Because in order to do this, I oversimplified this, But the first thing you need to understand and do is measure your carbon footprint, develop your pathway, and then implement and get a third-party verification for assurance. Those are very simple steps. Sounds very simple, but it's quite a journey. You can ask Caroline about her experience with all this journey so far. And just to finalize, the CO2 emissions data will be part or the new construction material now, because it's something that everybody will be looking at from now on in order to tackle global warming. I think that was pretty much my last one. Thank you very much.
Thank you, Manuel. Thank you. And thank you to all our speakers as well, to Caroline, to Finnian, and to Manuel. We did ask just before the webinar started if anybody had any questions. So I will just ask the room here. If anyone has any questions, you can pop them into our Q&A section or into the chat box as well. So one for you, Finnian, was, will CORE assist with design for carbon calculations or support us in planning?
Absolutely, yeah, of course we can, Lisa. We have all our EPDs, and we're happy to support anyone with their journey. It is a little bit difficult to get your head around at the start, but once you get it, it's very easy. So absolutely happy for anyone to reach out and talk to us on it.
Just
another one, Aidan.
yeah, just I suppose also, I mean, one of the things that Finnian marked upon is how the EPDs are, when you're looking at them now, they present data in different formats, and it's the interpretation of that data. SEAI have a team working on the standardization of EPDs so that every single EPD that will be produced in the future, don't exactly know right now what that future date is. I'd expect that it'll align with 2028 and the introduction of the directive. At that point, we'll all have to report based on the same unit. That will be a major help to the industry, because as you see, do you take generic values? Do you take, how do you, on the face of looking at the data, read it right and make a decision? So if you looked at the face of some of that, you could design in any product into your project. You get so far down the line and you realize that I've specified this product, I've looked at this product, but now we've got to take it out, or we've got to come up with some other solution because the interpretation of the data was wrong at that time. And it's yielding a different result than what we thought it was. Yeah. Sorry.
Another follow-on from that one for you, Finnian. What is the best way to select materials when you don't have the carbon data?
Well, it largely depends on your material, I suppose, Lisa. Of course, I'm going to say EPS is always your first go-to choice. But really, if you're not getting the data, then I'd suggest that's a bit of a red flag. Any reputable manufacturer should have the data available, and it should be there and relatively easy to interpret. But in short, EPS, pick EPS.
Yeah. It's the generic data then, isn't it, Finnian, really? Like you're going to the one that the industry will, with the generic data, will always have, I suppose, that it'll always be reporting on data that's at a higher kind of like that higher end. Yeah. And so if you have the EPD, you could design your project based on generic data. Come along correct. Then and and CORE goes in, and you realize that you have your carbon embodied carbon figure for your project has come down, but it could have been at a time when too late in the project where you could have balanced off something else, or so it's the danger of the generic, but that's your go-to if you don't have the data.
It is, and it's somewhat similar to BERs and your backstop values. If you consider how good or how much improved your BER can be when you deviate away from what's standard. So once you have all your accredited or your acceptable construction details, you can suddenly change your value and improve your BER. In a similar way with the embodied carbon results, if you're relying on those backstops, you're as you've already suggested there, you're potentially losing capacity elsewhere. So you're trying to shave off concrete somewhere. You're not able to use a particular cladding that you wanted to use because it's driving your figure up. So, if your big win is certainly on replacing where you can with low carbon products, and EPS is a really easy way to do that.
The other thing that has to be considered, obviously, there are products at early stage of development with very, very low or negative embodied carbon figures. We're at the forefront of some of that work here in CORE, but the reality is the supply chains aren't secure enough for mainstream construction yet. So that's part of when you're looking at what you'll be designing now, what you'll be designing 2035, 2040, and so forth. The playing field is always changing. But a point that came to mind there just when Finnian was talking. So at the moment, the SAI are developing. So how are we going to report on this? So we'll have a target. We're going to have a target to meet. The industry is going to have to target. At the moment, we report on meeting the targets of Part L with the deep software. So SAI will have a software, but for the first time, they're going to be opening up the specification or the compliance space to other companies that have lifecycle analysis tools, like OneClick, as I think Manuel had on his presentation. And so these software companies have to apply to the Irish government to be an approved verification tool, or not verification is the wrong word, but a compliance tool or calculation tool. The SAI will look at their software, make sure that it is giving the figures and the outputs in line with the legislative requirements. And then at the back of each of those tools, companies like us can say, please upload our data. But likewise, there'll be the tools that will give you all the generic data as well. So you'll whatever your steel requirements or your slates versus tiles on the roof, whatever it is, and you'll be able to pull that data down through these softwares as we go.
Manuel, we've got one for you as well. How can organizations embed carbon measurements into day-to-day operations rather than just a once-a-year reporting?
That's a very good question, and it has to do, I would say, with the data management system that they have. Usually, it would be, I would say, the International Day of Data, when they try to put everything together only once a year, instead of systematically having a management system that will keep track of the data. For example, energy management system based on ISO 50001 will have the figures of your energy consumption on electricity, gas, water usage. You will keep track of the data of your waste. And then if you have a fleet, you keep data on a monthly basis of all the emissions related to your fuel consumption, So once you put a system in place, you will be able to start bringing that data and having, you can learn to automate all this. Yeah, you can put an app, you can do it manually, but that's a very good question. If you are able to start understanding that and then getting the data, you will be able to tackle that better. Also, with all your materials, then you will have to have all the information on purchasing materials. And this, I would say, is the most difficult one, because companies, they can, manage their, their utilities, their energy, all that. But they usually will only have a PO for purchasing cement, but sometimes they don't even keep track of the amount of cement they bought. They only keep track of the euros they spent. So you will need to put systems in place in order to keep track of that, probably, I would suggest, on a monthly basis at least.
Yeah. One of the things we did here, so the first time we went through all that pain. Like, you know, you've got to understand the flights your team take, where they travel to, taxis, hotels, where do they go to in the like when you get down into the granular level of detail, and you feel that pain that first year you do it. So our account system and entry process now is we're set up cost centers, and so if we see a flight come in, we're entering in the miles. We're same with taxis. So the team are giving information on the start point and destination point for the taxis. That's added into the account system, because it's that, to Manuel's point, we're procuring most of these things that we're measuring. And so when you procure it and you understand the unit you have to report on, so accounts are interested in reporting things in money, and if in sustainability we have we have to measure it on different units, relating it back to a carbon output. And so that's what we did. We set up our account system that at entry point we're entering the data rather than trawling back through the data afterwards. And so that's like those small things. So it's just one entry point and we can run reports off that. It depends on the size of your plant. Like here in Core now, we understand all of these points of data that we have from every single machine, every single operation, and right out into our supply chain, but you know, all the things that are happening. So we're working on our data infrastructure, and we have a project going with Hydro where we're looking at creating data lakes so that we're starting on the basis of our data lake is our sustainability lake, and we're pulling all the data related to that in there, and we are able to run reports on that data. So it's kind of like giving you the tool in the future to layer in your AI and how do we drive the data meaningfully. And I think that for me, in our journey and what we're doing, that's the key. It's making it easy to get the data and analyze the data. And when you take the pain out of that, it makes it a whole lot easier. Obviously, we have pain in terms of what decision do we make? How do we fund that? How are we going to spend that? And that's to anybody looking at their supply chain at the moment and looking at specifying a product. If your supplier is not currently investing, and I don't mean in measuring, I mean investing in an activity that will lead to an improvement in your carbon or your data. So you actually have made a meaningful impact that then translates into your EPD to show that you have less carbon tons per cubic meter of whatever material they're making. If they're not doing that now, that won't be in their EPD in 2 years' time. Mm-hmm. That's the critical thing. And so and that's where the competitive advantage comes from, Manuel, because it takes 2 to 3 years to catch up on somebody that's already out of the traps.
Exactly.
It takes 2 to 3 years. Point. Yeah. We're over. Sorry. Look at me. Chat.
Just a final question for you, Manuel. You spoke about some barriers. And what would you say is the biggest barrier for Irish construction industries, like companies within there? And also, what would be your next step for them to do? And probably for yourself, Caroline, when you started that journey for Core, what would your advice be? And Manuel, first of all, what barrier would you feel for the Irish construction industry?
I think I will repeat what I said. I think the largest barrier will be the data management, the acquisition of correct data that will lead to give us an idea of what is the current performance of the organizations. I had a lot of barriers of people. We go back and forth with clients trying to ask them, to give us data, and it's because of the pain that Caroline was talking. They have to start digging back into their ledgers, trying to find out, for a reporting year, where that data is, because it is new. They're not used to, keeping track of that data. And the other one, I would say, will be the skills, the knowledge, what Finnian was explaining to us, that level of technicality. Not all companies will have a figure like Finnian capable to do that technical review and assessment of this. So they probably need consulting or assistance in order to do this. So those, just the high level, will be what I would say are the barriers: the data management, and then the knowledge to understand. Not everybody can understand an EPD, and just to understand what A1 to A3 is. What are the figures that I need to use? How could I do a comparison as Finnian did? Only technical people can do that, and sometimes organizations will lack or will have that barrier as well.
Caroline, any advice?
So the question is, what's the barriers within the construction industry? I think the barriers at the moment is that everybody's so busy, resources are always so stretched, that some of this stuff is now coming onto the page for some people. Definitely, it's what tier one contractors in the construction industry are doing and focusing on. They understand that green procurement and the requirement for green procurement coming from government, and they're going to have these requirements that you can't get a job, a construction build or design, unless you're going to be able to prove that you've got green credentials, or you have this built into your business models. So I think time is the barrier, and then it's, as to Manuel's, but it's confusing. You just bring in your consultant, you get them to work with a couple of key members in the team. You make sure somebody at the board level or director level really cares about this and is going to driven at director level in the organization, resourced, and then you do it. The other thing, I don't think people understand as well the help that's actually out there. The funding that's available, it's all outside. Most of it's outside de minimis, and so there are ways to do it. It's just making it important.
And I think we'll finish up there. And if you have any questions for any of our speakers, I've left the website for Core Installation and for CGBC there in the chat box. And you can also email us at marketing@coresystem.com if you require a CPD cert. Thanks everybody for your time, and thank you to our wonderful host of speakers as well.
Thank you.
Bye-bye.
Thank you.
Thank you.
Bye.
Bye.
Bye-bye.